Hello YouTube. So in this video, what I'm trying to do is I'm trying to actually apply this vector addition that I talked to you about in the previous video. I like basically work through an example and see how vector addition is done numerically. So suppose like I said, I'm having a vector A, and I know it is 30 degrees tilted with respect to the positive x-axis. And what else do I have? Well, let's say I have another vector that's, let's say, B, like so, and B is 60 degrees with respect to has 60 degrees angle with respect to the positive x direction. Now let's apply our knowledge that we earned in the previous video onto this one and get the vector addition of A plus B done. So R, this is what I'm trying to get to. I want to see what R is if I know A and B and how they are, how tilted they are. All right, so remember we said, well, the first thing is to basically anytime we have any type of vector quantity, we have to split basically their x and y components respectively. So this is AX, this is, I made a little mistake. So this is vector A. I'm going to be rewriting the components here. This is vector B. And then what I have is basically the addition of both of them, the resultant. And then we are good to go. All right. So remember we said, well, if we want to get the A, we have to basically make a right-angled triangle. This is going to be my AX. This side, this side is going to be AY. So this is going to be AX, this is AY, but well, sure, these are X and Y's, but let's get some numbers. Suppose A's magnitude is 5 and suppose B's magnitude is 7, all right? So let me just zoom into A and just redraw A so that we know how it looks like. Suppose, well, this is 5 and this is 30 degrees. So this is the AX, this is AY, and what we have here is basically, if you take a look at this triangle, you'll see that cos of 30 degrees is equal to adjacent over hypotenuse, which is A, right? So if I want to rewrite AX in terms of the A itself and the cos, then AX would be A cos 30 degrees. Does that make sense? Now A is 5, cos 30 degrees, check it out, but it is like about 0.866, and then we can get a number out of that. All right, so the number is going to be, it's going to be 4.3. All right, so it's 4.3, but it's not the end of the story. We always have to go and check if this is along the positive or along the negative direction. Remember, these are vectors, so their direction matters. We have our positive direction towards this way, AX is in the same direction, so this is going to be 4.3 and with positive sign. All right, so how about the y direction? So now for this case, what I'm trying to do is I'm trying to get AY. So for that, because it's opposite to the 30 degrees, it's best to write sine of 30 degrees. Sine of 30 degrees is opposite over the hypotenuse, and then AY would read A sine 30 degrees. So for that, then A is 5, sine of 30 degrees is 0.5, and the whole thing is going to give me 2.5. So then, like I said, this is not the end of the story. We always have to look and check what is the direction of AY. AY is in the positive direction, hence 2.5 enters in our column with its positive sign. All right? Do the same thing for B. Well, let's just zoom into B, and then we'll figure it out that way. So let's just let's just erase this little triangle over here, and let's just draw B over here. So B, let's say, is that. It looks like this, and then this is 60 degrees, as you already know. And then what we have to do is we have to split it into X and Y components respectively. So this is the Y component, which we know is exactly the same as this. So this is BY, this is B itself, and this is BX. All right. Let's just get it started again. Cos 60 degrees is adjacent over hypotenuse, and then BX is going to be B cos 60 degrees. And so BX is now B cos 60 degrees, and then B is already 7. We know that cos 60 degrees is 0.5. Let's just make this 5 look a little bit cuter. Doesn't hurt, does it? Nope. So that is 3.5. Let's see what is the direction of BX. It turns out it's in the same direction. It's as AX, so they're both positive. So we enter 3.5 with a positive sign in our on our chart. We'll do the same for BY. Then we have, what we have to do is basically now BY is opposite to that angle. So let's just figure that out, and then we go from there. So now sine of 60 degrees is opposite over hypotenuse, and then what we have is sine of 60 degrees is, well, just let's just write BY. Really doesn't matter, but since we have we've done it this way, well, let's just keep going with the same trend. So it's going to be B sine 60 degrees. B is 7. Sine 60 degrees is 0.86, and then that's gonna give us what was it, 7 times 0.86 is gonna give us 6 well, roughly 6, I would say. Yeah, there you go. So now for Rx is gonna be 7.8, and it's gonna be 8.5 for Ry. Now, if you wanna draw this out, this is how you would draw Rx and Ry. So let's just erase this triangle, and let's just draw R. So, and I wanna use another color because I don't feel like we are too colorful here. It's just getting pretty boring. Let's just use orange. So Rx is 7.8, and Ry is bigger, so it's about 8.5. So this is Ry. Then this is how we draw the whole R. Here is R. So as you know, if you take a look at this triangle, you'll see this is Rx, this is Ry, and this is going to be the hypotenuse. So R, the magnitude of R is square root of 7.8 squared plus 8.5 squared, and that gives you the answer for the for the R. So let's just do this. So what was it? 7.8 squared plus 8.5 squared, and that gives us 11.5. So as you see, this the size of this hypotenuse is, which is the resultant of A and B, is 11.5. But you may ask, well, didn't you say that vectors are they are not complete without their magnitude? We need some sort of other information, which namely the direction, to make it complete. My answer for you is yes, sure, you got it right. Let's just get the direction of R correct as well, and then we can go from there. For the direction of R, we usually have this conventional way of writing the direction, and mostly it's with respect to the positive x-axis, unless it states exactly what direction you're solving for, and I'll explain that in like other videos when I'm explaining more examples, or you ask me questions and I make a video on it. So this is my theta, and I want to get this theta because if I get to know what this angle is all about, then I exactly know how R is tilted. All right, let's just get that. So far, we know that R, the hypotenuse is 11.5. We know the Rx is 7.8. We know Ry was 8.5. And now what is this? Well, easy peasy. Tangent of this angle is opposite over adjacent. So opposite is 8.5. Adjacent is 7.8, and then what theta would be theta would be tan inverse of 8.5 over 7.8. All right, so that would be that. And then once we get to know, you just have to plug it into your calculator. Let's see what it is actually. So tan inverse of 8.5 divided by 7.8, and that should give us the angle in terms, it's actually 47.5. So the angle theta here is now 47.5. So this angle is 47 degrees 0.5. All right. So now we have all the info that we possibly need in order to make sure how R is looking like, basically to make sure how big it is, it's 11.5, and how tilted it is. It is 47.5 degrees with respect to the x-axis. So you do all these things with no matter how your vector looks like, you just have to split it into x and y components, and then you do the chart, you add, subtract, whatever you have to do with them, you get the resultant. The resultant has its x and y components, then you have the Pythagorean theorem in order to get the resultant out, and then you have you specify your angle. Once you specified your angle, then what you should do is basically use trig functions. Here it was just easy and handy to use tan, but make sure it is not all the time the same story. So always make sure you think through. And sometimes it's easier to use cos, sometimes it's easier to use sine. All in all, make sure you use the trig functions correctly to get the answer right. All right, I'll see you in the next video. Please share with your friends so that everyone basically learns as we go along with these series of in mechanics. If you have any questions, please comment it down below, and please, if you have if you give it a thumb up, then I can get to know if you like this video, or if you have any other suggestions, please just comment it kindly down below so that I get to know what you want me to explain to you and all that. So I'm a physicist. You can ask me any sort of questions you have, and I can just make a quick video out of it. All right, take care. Bye bye.